So hello everyone. I think we are recording now. I already put recording. So today is chapter 2 of LEED Green Associate Exam Preparation Complete course. We finished one part, which was the LEED process. Some people call it LEED project management. How to manage a LEED project. Because to manage, you need to know how to communicate. So we know all the communications. We know the rules of USGBC, GBCI, and LEED Online, how to apply for certification, what are the fees, what are the process you have when you have to communicate, what are the documents you communicate, and so on. Today, we will have a central chapter, small chapter, in the part 1 of the lecture, which is integrative process and system thinking. This chapter is central between the administration part. This chapter is central between the administration part and the technical part. And this is the start of the technical part. But it still have important concepts. So you need to be patient to understand these concepts. And my advice, you study this chapter twice, once now and one time after you finish all technical part and back again to this chapter to rethink these concepts. So the first part is we will go to system thinking first, then we'll go to integration. The intent here, the intent means, for Arabic speaking, المغزى يعني. Why integrative process and system thinking? To support high performance, cost-effective project outcome through early analysis of interrelationships among systems. Someone tell me if I want to how, يعني the how among through early analysis of interrelationships among system. Someone give me easy word that we are using in our project. Okay, give me easy word that we are going. Why we do coordination, integration, coordination, interrelationships between system means I do coordination, integration, and so on. Got it? So we need to always crack the concepts into easy and easy to understand concepts, because the exam is multiple choices, so not ask you exact wording and so on. System thinking. In the LEED, the overall, they are thinking the building is a system. So it's not proper to design the best wall insulation without having a glazing, meaning the glass panels, with also a good properties that can manage the solar radiation, okay, or good insulation for the roof, or ventilation through the buildings. So when we speak about all this, we can say the building is a system, like human bodies, like human bodies. خلاص? So system thinking, the built environment, when we think about our development as system, we will think that the building in the built environment, series of relationships in which each part affect many others, or if each part affect many other parts. Okay. طيب. Let's take the process of designing. If you are design consultancy, do you really reach out to the final drawings one time from the first time you just put the design? No. There is iterations, like iterative thinking. You always do revision 0, 1, 2, 3, 4 until you reach construction documents where you give to the contractor to build. Why you do that? Because you are always go and review and look at the system you design compare it or integrate it with other systems, and again do some change to let your system work with others. Okay. For example, here the buildings, can you see how you build electromechanical, which is active system. We call it always electromechanical. We call it active systems. And passive systems, walls and floors and foundation and heating. You see here heating at the floor. So why you put, what makes the decision to put heating, floor heating here, under floor heating like this? Okay. What makes your decision to put solar panels, to make the building roof looks like that? Okay. To put this window here, to make the size of the window this size. All this based on many factors related to outdoor climate, sun directions, insulation, heat transfer, material properties, and you cannot go through all these once. So I'm not saying these to complicate, make it complicated. No, I just these examples that you have. But what LEED want to say here, that the building, you can consider the building as a whole system. Okay? Like what? Like human body, although every organ have some job to do, but when you have your finger pain, you feel headache, right? So that's why. If I have the best insulation for the walls and I have glazing one layer, not double or triple layer, so it's useless. The insulation I did, still the heat will come in and will use more energy, something like that. See the anti-hill system, this is a system. The galaxy system, the bacteria system. So in our buildings, what is a system? The definition of the system. Exam question. Exam question. What is a system? Uh, this definition will come exactly with the wording in the exam. And will ask you, what is that? A system is an assemblage of elements, a group of elements, okay, or parts that interact in a series of relationships. There are relationships between these systems. You may have systems, but there is no relationship between these systems, right? But when I have systems that are in the same physical location, walls, floors, ceilings, or development project, every part is impacting every other parts. Okay, so the word interact in a series of relationship is the keyword here, where you will answer the many questions. Again, the word interact in a series of relationships is the keyword here. I always extract to use a keywords for the examination. So this definition, have a deep look in it, spend some time here, because a series of relationships mean systems. Systems can be divided into mechanical system in buildings, passive system, or basic building design. Basic building design, we know, just a design without any soul, but the passive and mechanical system, or sometimes we call these systems mechanical system, we name it active system. What is active system? Active, why mechanical is active? Mechanical is active because you have fluid of or liquid is running through a pipe, or fluid of electronics running through a wire. So they are active. They are not static thing like window or door or ceiling. So passive systems like static system in your buildings, active systems or mechanical or electromechanical systems are the uh, active systems. Okay. So this definition is important to define what is a system. Okay. Now, if I want to know the types of systems, since there are a system, there are two types of system: open system and closed system. Guess with me, what is most sustainable? What is aligned more with sustainability concepts, environmental, social, economic? Open system or closed system? Okay, we don't know. So let's know first what is open system. Open system like this. You buy the materials here, okay? You use the material like what you see here in the photo. After that, you send it to the waste dump here. So that's why they call it open, because open system always generate waste. It's open. It's an open process. Why? Let's see the closed system and we'll know why. Closed system, like see this the life cycle of animals and plants. You can see that uh, during the life cycle, for example, these animals release CO2 where the plants can use it, and then plants also generate CO2, and CO2 also and also need CO2 from this uh, kind of insects. And all in all these are supplement to each other. Every process of this, yani the animals eat plants, animals die, decompose. Who will eat the animals? This kind of uh, this organism. So all these will integrate together in a closed cycle. Let's take another example: the water life cycle. When the water it's raining, uh, as a rain, precipitation or rain, what will happen? There are lakes will come, or the water will infiltrate in the soil. This is the soil, or go in some lakes and make some small lakes, or to the sea and water and so on. Okay. Then the sun will come, and the solar radiation here will hit the water surface and it will evaporate. After evaporation, what will happen?
Ashraf,
Yes.
I'm sorry. I think the slide it's fixed on open system, not moved.
Okay. Thank you for notice.
Welcome.
So I will share it in another different way. Let's just share my screen of my laptop. I think now you can see it.
Yes,
You
thank
can
you.
see even what I'm doing here. So like what you can see here, the systems, closed system, something like the water cycle, as I said, uh, the water cycle, rain, then infiltration in the soil, or going to the lakes and rivers, and then evaporation, and then again clouds, again rain. So this is closed system. Also, our life here on Earth. Animals eat plants. Plants is food for animals. Animals die and decompose, become through these insects. Also, plants can also take nutrition from these animals and insects after decomposing. So it's all together, work together. I don't see here any waste going out. Do you see any waste? Do you see any waste in the water cycle? That's why, that's why this is a closed system. Now, the open system looks like this. Let me check how you can see the screen. Yes, this is the open system, and closed system looks like that. I don't think any delay in the screen now. So what do you think? Which one is more sustainable? We are learning a concept that we will apply in all the coming chapters. It's a concept. So open system, closed system. Of course, closed system is more sustainable. Why? Because no waste. Because no waste. Open system always generate waste. Open system will end very soon, or will you will have like oil, petrol and oil and so on. It's an open system. A source of material, we use it for energy, and after that, it will become greenhouse gases like CO2 and so on. This is open system. But when we go and take the oil, when we burn it in cars, and again collect the CO2 from the air, and this CO2 go to any industrial process, this become now semi-closed system. So why? We try to get the material to back to its origin. Not exact origin, but to go to another process. Another way. Let's say a material like what you see here, wood or whatever, used and then sent to waste dump. But I take it instead of sending to waste dump here, and I go to factory and I make a new material. Let's say a plastic bottle. After that, I make from the plastic bottles a table chair, plastic also. I used in some parts of car manufacturing. All this, okay? So, but if I just send to waste, this is open. So from there, the closed system is more sustainable. Why? Because always the process is continuous and there is no waste. The impact on our sustainable development or development that we always think about buildings in the same way. We learn from how our surroundings or our systems work. There is open system and closed system. So if I am building a development like this, so we must understand that first, these are systems. These buildings consume materials. These buildings generate waste. Okay, consume energy. These buildings generate greenhouse gas. Okay, will we leave these buildings that just like open system, a source of material come in for buildings, then material come in for operations, then out the waste, and this is open system? Or we do try to mimic or make like the closed system and try always for materials and waste to be recycled, for energy to reduce energy, to generate green power, to think about net zero buildings. So from there, we are coming through the concept of closed systems. And it's very important now to understand what we are doing in sustainability. We are turning open systems into closed systems. Can we do that? Can we do that? Of course, we are trying and we're still trying. So, for example, using better insulation for more efficient windows might allow for a smaller heating system. So now I reduce it. I reduce what? I reduce energy by good insulation for the walls. Unfortunately, you find our old homes or our homes or even expensive buildings, when you buy apartment here or there, you find there is no good insulation. The sun is hitting the building and then you have a big electricity bill because the walls are heated too much all the day. Most of the building, even in some cities in the Middle East, all the Middle East, they are not considering or spending some money for our simple buildings. I'm not speaking about mega projects and so on. No, they need to design to put standard for insulation. So this will reduce power not less than 30%, at minimum 30%. You have reduction in power for some good insulation, and good glazing. So building standard need to consider sustainability, need to consider open and closed system, need to consider always how to think about the buildings as a system, generate, interact with the environment, impact the environment with the waste, with the carbon, and so on. The feedback loop. What is feedback loop? It's like feedback. Let me send you email and I don't know, it's arrived to you. So you will reply to me, receive it. But here, feedback, we speak about systems like thermostat in the ref. The thermostat, when it reach always the refrigerator in your home, when it reach some temperature, it will shut down and then start again. Shut down, start again. Why? Because based on the feedback that it reached to the freezing temperature. So no need to more, otherwise it will destroy your ref. Okay. Some systems now also use this feedback not to stop the system, but to reduce the speed of the system, which is even better. Like in some air conditioning systems now, plate you can find in your home, something we call, you can see in the market, and so you see this air condition split is inverter, the other one is normal. What is the inverter? The normal just start, stop, start, stop. The feedback of it, there is feedback. If you put it in auto, yes, there is feedback, because when it reaches temperature, it will automatically turn it off, the cooling off. But the new inverter, it will reduce the speed and increase the speed. Why? Because they told you the starting take always energy. The starting of the system always to consume energy. So they just say, okay, let's make this air condition just continuous working, the fan, but it will speed up or slow down. Speed up, slow down. So it's always running, but in a low speed or high speed. Depend on you reach the feedback point or you reach the temperature you set or not. Okay. What is also feedback loop application in our building? Sensors. Sensors in our building. Motion sensors, CO2 sensors. When you reach the CO2, let's say densely space. One space is very occupied in your building. So the feedback loop is very important here to know when you give ventilation, when no. Not giving just random and excessive ventilation, which consume more energy. Okay. So this is the feedback loop in a simple way. And in exam, they will not ask you if you understand what does it mean feedback loop. The way I explain, you can deal with anything or any question. Let's say here, building without appropriate sensors and control systems such as a thermostat cannot adjust to changing temperature and maintain comfortable indoor. This is first. You see this guy is putting. Not only that, but without sensor, you will consume more energy. Another example, the car. Do you know Toyota Prius, the first, one of the first hybrid cars? And now we are familiar, everyone is familiar with hybrid. I was explaining this 10 years ago and nobody know what is the hybrid. Now everyone know hybrid. The Toyota Prius or the Prius effect, they take it from Toyota Prius because it's first car that put the screen, the battery, the engine, and so on, and how all this integrated together with the wheel and speed and so on. It also give you what is the consumption. See here, consumption. If you stay at this speed, what is your consumption? Miles per liter, per liters. Oh, miles per gallon. Miles per gallon. And if you increase the speed, it will give you. So it's always temperature. It always give you feedback. Based on this feedback, you take manual action by yourself. It's not automatic action now. You speed up, you slow down, depend on your decision. That's why we call it Broad effect. Hybrid vehicle which display energy in detail, which result in caution driving of owners and reduction in energy consumption. Okay. طبعا, of course, if you reduce the speed, it's a negative feedback. There is two feedback. Feedback means the decision you will make. It give you feedback. So negative feedback means your decision is to reduce speed. Your decision is to close the air conditioner or slow the speed of inverter air conditioner or the thermostat of your ref. Okay. There is also positive feedback where you need to speed up. Let's say here in very slow speed, you are consuming not 99.9 meter per gallon. No, you will spend maybe more petrol or less distance. So you know that you need to speed up a little bit to reduce the energy consumption or the petrol. So this is a concepts as examples just to build up our idea how to think about systems and feedback types of systems and so on. The always the point where we take action, like you take action to speed up, we call it leverage point. Leverage point. Okay, so leverage points that affect a system and produce a meaningful change. So when I reach to this temperature, let's say your ref, in your house, now it reached temperature only 4 degree. When the 4 degree reached in the normal, and the ref will turn off the cooling. All right. When it will start again? Now, once you turn off the cooling at 4, it will be 3.9. It will be 3.89, 3.79. When you can start again, this is the leverage point. So you decide, of course, you cannot turn off at 4 degree and it will remain at 4. It will go down. Also, if it go down 0.0001, it will start again. Of course, no, it will not take 2 seconds. No, there is leverage point. You take decision. If it reaches 3 degrees, then the ref will start again working. Start again working or accelerate again. So this we call it leverage point. Point where action should be taken. Leverage points can be decided manually. You can preset it or automatically. Nested systems. Before we go to the concept of nested systems, we are moving from concept to another that will apply in all our technical part later. Nested systems, guys, is systems that are running without building within our buildings. But these systems, which one is important, or which one includes the other? Let's say again, go to human body. Let's go to human body, the one we discussed earlier. Is a system. I told you, if someone have injury in his arm or his leg, all his body is sick. All. Why? Although this is just a small injury, but he's not feeling well. He cannot focus. He cannot concentrate. He have pain in his body. He have headache. So the same our building systems. Even though systems are like this, electrical feeding HVAC, and HVAC have dehumidification system, and then building envelope enclose all this. The envelope is the outer skin of the building, like cladding, like outer wall of the buildings. We call it envelope, building envelope. The outer walls of the buildings are the building envelope. So if you tell me the envelope is the most important, I will tell you yes. But what about electric system? What about dehumidification system, HVAC system? I have good envelope, but in envelope and HVAC system, not there. It means people will cannot breathe, right? And the same HVAC system with envelope which have leakage will lead to inefficient systems, excessive energy consumption, and so on. So systems are always nested. Everyone supplies the others, or everyone is uh, uh, give feedback to the other systems. There are some important systems and some simple systems, but all are important. Having any trouble or any issue with any system will impact the other system, because at the end they are nested systems. They are integrated together. They are integrated together. So buildings are part of the world nested systems that affect and are affected by another. They are impacting each other. Once the project team understands the network of systems that affect a given project, the energy and matter that flow through these systems, and the relationships and the interdependencies that exist, the deeper and more effectively integration can occur. The more you understand how these systems work, and how they are integrated together, the more you can do energy saving, and you do achieve efficiency. So modern projects now need engineer who have the knowledge not only of his area, but he know how to integrate and cooperate with other engineers, like what we see here. Okay, and that part was system thinking. The definition of system thinking is enough for me. The concepts we explained, the open and closed system, and so on. Now we'll go to the second part of this chapter, which is integrative process. 50 years ago, I will not say even 20, 50 years, we was going, I'm owner, I bring an architect, make nice design, and then after that, almost done. The civil engineer will put the columns and the contractor start work. Did the lighting, put his light, the air condition, and so on. There is no integration here. There is no any feedback. It's one line, linear. Can you see it? So it is one linear process starting from owner, go here, like this, one line. And then the outer here, the output is your buildings. But here there is no sustainability, no integration, no system thinking, nothing happened. If I want to design nowadays a building, we will not do it by conventional process, but we will do it by the uh, integrative process. Okay, what is integrative process? Integrative process, like what we see here. At the core of the process, the design team, the basic design, where I have as an architect all the other disciplines surrounding me, starting from HVAC, acoustics. Owner represent also have input. So input from specialities or experts, and input from stakeholders, and so on. All this based on my initial design, I will send to them, get feedback. There is no linear here. It will not come back like what we see in linear process or traditional or conventional process. No, integrative process. I have seen this. The lighting specialist will put his lighting design and advise for some modification in the architecture design. The same for contractor, constructability, what you said. They will send some advice. Even cost consultant, security, communication, okay? Fire specialist, owners. So design now is very integrated, and integrative process is a normal output of a integrative process. Do you think that before we involve security? Do you know that now security is very important? There is one concept, for example, in security we call is septed. Septed, like this word is many words, like security or implementing security based on by implementing environmental elements within your design. So instead of putting a security guard, no, you put a fence, looks like architectural fence, very nice. You put some distance between the gate and the buildings. The circulation, you consider some security while people are moving within the building and so on. So all these are parts of the integrative design. And I think now when you hear this course, you should also think about some specific areas you are doing in your discipline or scope, and you will think of it. You will think again of it in a in a different way. In a different way. This is integrative process. So we do also integration within LEED. Through a LEED kick-off meeting, but in here we call it LEED charity. LEED charity or charity. It's a goal setting workshop. Do you remember the kick-off meeting in construction at the end of planning and starting in construction? Okay, do you remember it? Yeah, something like that. But here we discuss what? We discuss the lead target, the project goal, the target score rating or level, gold or platinum or what. So you need always to know what is the process. The lead process start with a charity or a goal setting workshop where you decide the strategies for lead and the rating system, what credits you will do, what prerequisite you will do, and so on. Okay. So remember, what is that charity? It's a goal setting workshop. Okay. Integrative process in lead go through some phases. Let's say discovery phase, design and construction, implementation, and operation and performance feedback. Take a screenshot or photo for this screen. Okay. All right. So here, this is the phases: discovery, design, and construction. These are the phases of integration or integrative process in lead. Equivalent to it in our traditional design: pre-design phase, schematic design phase, occupancy. What I really care, I want you to remember this. What are the phases of integrative process? Discovery, design and construction, implementation, operation. Agree? These three important. It will come question now. Okay, I will answer with you the questions today for this chapter. Okay, and next chapter we will give you homework. Uh, okay. Discovery phase. Discovery phase, like any project you do as an architect, what you do in the discovery phase? or a pre-concept. You understand the requirements, right? You establish goals. You put, in addition to here for LEED projects, you establish some targets, like you collect information from the owners. What are the targets you want to save water, save energy, and so on. So there is always additional step to your work will be done in every phase. That's why we said LEED for all engineers need to be LEED, regardless they will work as a LEED or sustainability or no. They need to know what is required from them, so they need to take LEED. That's why we are here. For just small information, very simple information, you can have a big mistake in the design, a miss in the design. Design and construction. Here, all the process of the design go normally like any normal projects, but in the design, which go through some phases also of design, you need to start to think more about the systems you will use. I know that my target is 40% water saving, but how? Will I install water treating systems? Will I collect rainwater? Will I have some storage tanks for water underground or another thing like above the building or what? All these are decisions. You need to think more in details here and start to select the systems based on your targets in the discovery phase. So if I say in discovery phase, I need the building to be net zero, like for sure during the design, I will start to think of renewable energy system, photovoltaics to install, and think where I will bring the area of the photovoltaics. I have no space in the roof. Maybe I will put in the building facade, here in the facade, like new. Are they effective, or I need to change my vision again back to the discovery concept and convince the team that it's not economic? So you need to think about all this in the design phase. In the operation, of course, you will start to measure the performance. The operation always about measurement. You measure what you have designed and constructed. Okay. So example, project should continuously monitor energy through what? Through energy bills, through meters, and so on. That is the chapter. Very nice chapter, full of concepts, full of applications, some concepts that will apply later in the other chapters. Very interesting about system thinking and how integrates integration and so on. It's a new era in design and construction. For sure, you are working in this way. But as we said, we always add one more step related to sustainability, to LEED requirements. That when we miss it, even it's simple, we are missing a lot. Now, let's have questions. I will answer with you the questions for this chapter, but next one, which will be after break, you will take a homework and we'll discuss it next next Saturday with chapter 1, the LEED process. Integrative process. I will take names like if as usual, Mr. Ali Al Sawar. Please read the question. Let's think together. It's not the matter of answering or no, but let's think together. Okay? Yes, go ahead.
Questions number 1, right?
Yes, right.
Okay. In the design and construction phase of the integrative process, how does the integrative process differ from the conventional design process?
This question say is in the design and construction phase. Yani during design and construction, clear. Of the integrative process means I have project, have integrative process. Good, yani good projects. Like all your projects now, all international projects apply integrative process. How does the integrative process different from conventional process design? So I think this question should have started from here. How does the integrative process differ from conventional process? What is the difference between integrative process and conventional process that we have just now? That is the question. Now you can read the multiple choice. Like the integrative process is when financing will occur? Of course no. The integrative process will incorporate all of the collective understanding of system interactions that were found during discovery. I would say no, yes, but not this answer. No, this is not the answer. They always give you correct answer nearby, and answer very far out of the scope. So let's read C. The integrative process design phase expect each discipline practitioner to design assemblies and system component under his own control for the most benefit and the least cost. They're giving you wrong with correct information. How come, guys, in C, integrative process, they always here in the question here will focus what is the meaning of integrative process and what is the meaning of system thinking. If you understand, you will answer. See here, the under his own. Can you see this word? Under his own control. I don't think anyone under anyone's controls only. We need to discuss. There is integration, there is coordination between discipline. So there is no discipline where take one, the architect will not draw one line and one wall thickness without having coordination with other team that will advise the insulation or at least agree on what he. So there is nothing in under your own. This will call it linear process, single process. Yeah. So C is not, and A also is not. So we still have B. When I said, yeah, this is near answer. The integrative process design phase will include the architect's preliminary renderings. It's like he's taking you like far, like playing with you. Okay, but what is the renderings? What is the relation? I want to explain clearly what is integrative process. So I think now the B was the nearest to the right answer. The integrative process, design and construction. See, even here he mentioned design and construction. The integration happen in design and construction. Here all say design, design, design. This is one thing. Okay? Will incorporate all of collective understanding of system interaction that were found during discovery. That is 100% correct. During discovery, I put targets, targets, targets. And then when it comes to design and construction phase for integration, I start to incorporate these targets and think about systems and how these systems will interact together. Okay? If you don't know this, go back to the slide, read it once, twice, and so on. You will find this is the right answer, B. Next one, let's go to Engineer Anwar.
Yes, with you, engineer.
Okay, go ahead.
What is that? The core of the integrative process. Cost-based decision making, linear planning, working toward individual goals, collaborative team members. I will go with D because we are talking about the coordination between all systems.
Okay, excellent. So engineer, if I want to delete the first one to delete, يعني I want to also to teach you exam strategy. The first one that you are sure it's not the answer. Which one?
The cost-based decision making.
And what? And also what?
Working toward individual because we are team here. We
One
should
integrate.
coordinate together.
Excellent.
Integrative.
Excellent. Next is, I think, let me see the list is Engineer Ayman. Dr. Ayman is the coordinator. So Engineer Bader Al-Utaybi.
Yes, indeed.
Go ahead, please. Number 3.
Which of the following are phases of a leader interrupted progress?
طبعا ده احنا قلت لكم خدوا I said take screenshots, right? I said take screenshots.
Mhm.
It's a direct. If you take screenshots, it is what? Let's see
Discovery, I think D.
the answers you have.
Discovery,
There is 3 phases. Discovery, yes.
discovery and design and construction and
Yes.
operation.
And operation, the last one. Operational performance. So as you can see, when you listen to my lectures again, it's recorded. When I tell you study this, remember that, you will find it in the exam, you will find it in the questions. Okay? Because I have 20 years giving this course, so I know what is will come in the exam, what he will test you. Even the exam come difficult, it will be about the same concept. He cannot go far. It's not PMP, okay? It's not PMP. The more you make efforts here to understand, focus, analyze every word, the more you will go exam, you'll find everything is very easy. Next question. What is a major? I will answer this one because it's 2 parts, so difficult for you to read. What major concepts are integral to green building and sustainability? Exam strategy here applied, choose 3. One time I just forget and I think choose one, and I found more than one correct answer. And I was really disappointed. These or these or these 3 answers I found. At the end and after I lost many minutes, I find choose 3. Oh, okay, I was right. So you need always to focus in these areas where some people get confused in the exam. Really, they will not see. They will not see it. So the integral of sustainability in design and build project is integrative process, system thinking, and we'll add to it what? Here, the exam strategy. I don't know these 3. And Ashraf did not tell me about them. Okay, you have your mind and give you the concept. Open systems are good or no? We said bad. Open system generate waste. Linear planning is good or no? No, we said linear planning means it's not integrative. It's a linear process, not integrative process. So I delete this. What is the remaining? Life cycle approach. Suppose I don't take life cycle approach. I don't know life cycle approach. It will be in the next chapters, but I can answer the question. That's why some people, when they take questions, simulation or something before the exam questions, they will tell me, you did not put, you put this question, but you did not explain to us this. We don't know life cycle approach. You did not explain it. In this case, they are right. They are thinking right. Of course, no. He has the right in the exam to put to you here anything from what you take in LEED Green Associate or from any other source. But if you trust yourself, you have confidence that you studied well, you can choose the answer that you know with confidence because you studied it in the course. So you will know what is the answer, or you eliminate the wrong answer. Okay? Okay. What is not, I think, who is the next for the next question? Engineer Ahmed. What is not a principle? Meaning, what is not a principle that should be followed for successful green building project? It means all of them are principles, all of them are correct, all of them you know them, except one. This one you may don't know at all, or you may know it, but they provide it wrong. So the answer here that all of these correct except one. Or sorry, no, all is not principle that should be followed for successful green. What is not? What is not? No, I'm right. What is not principle? So all of them are principles except one. Multidisciplinary approach. No, it's good. Commitment to process. It's good. Long-term savings. Let's think about it later. Budgeting the planning and design cost separately from the operation cost, which is not really what makes sense. Not really good, because separately, the word separately, you can read now between the lines. Separately integrative. It's against our concepts, right? Commitment to green building early. That's good. So the answer is, of course, D. Okay. Number 6. Which of the following is considered the most important phase of integrative process? This one, I need all your opinions, all of you. I will open the chat box. What is the most important of the 3 phases of integrative process? We have discovery phase, we have design and construction, we have occupancy. These are the 3 phases. I already told you. خلاص? These are the 3 phases of the integrative process: discovery, design, and CBA. In arrangement, arrange it CBA. This is the 3. But he's asking here, what is the most important one of these 3, of C and B and A? Discovery, construction, which is B, or occupancy? The phase, yes, you are right. I think you are right. Discovery phase is very important, because it's like the plan, the roadmap. If I will say, if I'll design photovoltaics, I make recycle water, I should have discussed early with the owner. Yes? I should have discussed early with the owner to take decision, because this one word will be followed by a lot of work in design and construction. It's a system I will design. So don't start from last. Okay? You can always think about C and B, but I can see the discovery phase is the most important, because it is the phase where you take decision, where you give directions. The owner will say one word, I need LEED Platinum, and he will let the project team work for 3 years to achieve the LEED Platinum. Why? This is the targets, the goals. Okay? So remember that. Number 8. Just to see it, I cannot. Yeah. Number 8. Which of the following best describes the LEED chariot? LEED chariot is a goal-setting workshop, guys, and we have the definition. But let's read here how he want to make you confused. At least 8 hours. Who say 8 hours? So I exclude it. Intensive multi-party workshop. Bring people from different disciplines and background to explore together. Together I like. Why? Integration. To explore, generate, collaborate, produce design option. Produce design option. Produce design option, I have doubt. Why? It's a chariot. Design option, he mean here concept, or he mean design option like they think about details of the design? If it means they think about details of design, it's wrong, of course, because I'm still in the kickoff meeting. Okay, but I will keep it to the last. I will back to this B. I will just mark this word, but I will see the others. Why? Sometimes they always give you the answer that is most correct. Okay. The operational handoff. between the project team and the facility manager. Of course, this is at the end of the project. This is totally wrong. I will exclude. Meeting with project team at least monthly. Of course, this is a monthly meeting, not a kick-off meeting. So based on everyone I excluded, while sure I was only doubt here, I was thinking about design option. So I can translate produce design option means directions here. He means the direction. What systems I will do in the kick-off meeting of LEED charity. The owner want 40% saving in water. What systems I will do? Do I have to recycle or I just use water saving faucets and showers and all this that will take in the water chapter? So the B is the answer. That's why this chapter, guys, I see it's very, very important. After you finish all the technical parts, you back to this and listen to this video. You will enjoy it. You will see how this really related to every chapter. So B, anyway, B is the right answer. At the end of the course, I will give you all the answers in one sheet. Number 9 and last, what is example of a project team applying system thinking and integrative process? Focus on the first cost. Of course, like this is not integration. So first cost only? No, I always focus on the life cycle cost. Ending the green building process when the project team hands the site over to owner. It means, خلاص, if I hand over, no relationship. خلاص, I cut the relationship. No, it is not like that. So either C or D. One team, see, from the first word, one team member, only one individual. This give you the impression that this is a system or integrative process. One team member completes the design of the system and hand off to the next team. This is what a linear process. So based on these three, they are not the answer. I think now you know the right answer. Establish water saving metrics for measuring success. That is the answer. Even though you don't really convince for what does it mean, but I think by deleting or eliminating all this, you will find the answer. And he want you to do that. He give you answer here that is not clear, but the wrong ones is very clear. I hope this was clear and you enjoy the integrative process and system thinking. We will have half an hour break where you can do a prayer and we'll come back after 30 minutes almost. So let's say 12:45 sharp, we will start. Thank you very much. Thank you.